Namaste. I live in Gaurav from the Faculty of Physiotherapy and Diagnostic FP in the Department of Diagnostic and Community Health in the discipline of radiology. Today we are going to discuss about the session that is important for general radiation second and radiographic technique of full body for BScRT second instrument. I am from Vidyapeeth University. Thank you. The session is over. I think this session is very much useful for you or very much interesting for you. I think you are satisfied with this session. If you have any queries, then put it into the comment box. I will resolve it later. Thank you. This session is over. The session is powered by digital version 2.0. Vidyapeeth University. Thank you. Okay. In today's session, we will discuss about the filtration, added and inherent filtration. In the previous session, we discussed about the X-ray tubes, different types of X-ray tubes like historical cassette tube and Coolidge tube. Okay. So this session is very much important because after filtration, we can get a useful X-ray view. Okay. Filter. A filter is a metallic sheet introduced in a part of the X-ray in order to reduce the patient load. So it is used or insert in the part of the X-ray in order to reduce the patient load. Okay. Diagnostic X-ray consists of both low energy and high energy X-ray. Okay. When X-ray pass through a patient, only the high energy X-ray penetrate through the patient and form the image. So low energy X-rays are absorbed in the first few centimeters of tissue. Okay, first few centimeters of tissue, thereby increasing the radiation dose. Okay, so it absorbed the low energy X-rays are absorbed in the few centimeters, first few centimeters of tissue, and after that only high energy X-rays penetrate through the patient and form the image. The introduction of filter absorbs the low energy X-rays and reduce the patient dose. Okay. This process of removing the low energy X-rays by introducing metallic sheet is called filtration. Or filtration. Filtration has two types, namely, first one is the inherent filtration, second one is the added filtration. Okay, so let me discuss about the inherent and added filtration. Filtration resulting from the absorption of the X-ray by the X-ray tube and its housing, like collimator, like focusing field of collimator and shutter. Okay, so X-ray tube and its housing is called inherent filtration. Housing means glass or any type of material that is used in the housing or X-ray tube. This usually varies between 0.5 to 1 mm of aluminum equivalent. Okay. Next one is added filtration. So what is added filtration? Added filtration from absorber placed in the path of the instrument, like collimator, like any type of absorber, like a block. Okay. That is the added filtration from absorber placed in the path of the X-ray beam. Okay. The sum of the inherent and added filtration gives the total filtration. So we can get a total filtration after adding the inherent and added filtration. Okay. Total filtration is equal to inherent filtration plus added filtration. filtration. So this filtration is particularly important because the low energy X-ray also exists, the X-ray beam. So after removing, after filtering the low energy X-ray beam from the total beam, then we can get a high energy useful X-ray beam. So we can reduce patient dose after filtering the low energy X-ray beam or absorbing the low energy X-ray beam at a few centimeters. Okay, thank you. Okay, in today's session we are discussing about the historical X-ray tube. That is historical because it is the tube were used in initially in the beginning. Okay, so it is a historical, but it is also called a gas X-ray tube because the gases are filled in the X-ray tube. Okay, so let me discuss about the historical or gas X-ray tube. In the beginning, gas-filled X-ray tubes were used. Gas-filled X-ray tubes were used to produce X-rays. Okay, these tubes consist two electrodes called cathode and anode. Okay, or kept in a sealed glass envelope. So sealed glass envelope is enclosing these electrodes, cathode and anode. At opposite end, the cathode is an aluminum stem. So uh, 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 cathode is an aluminum stem carrying a concave aluminum disc. Or in the coolest tube, there is a tungsten filament. So those both tubes are different in the construction of cathode. Okay, the anode of target is tungsten or platinum baked with copper. Okay, anode of target is tungsten or platinum baked with copper. So copper is a block, is in the shape of block, and tungsten or platinum baked in the copper. So the radius of concavity of the cathode is such that its center of focus lies on the surface of the target. Means if it is a target, okay, this is the cathode, then concavity of the cathode is such that its center of focus lies on the surface of the target. Target की surface जो होती है उस पर lie करता है. Okay, the face of the target makes an angle 45 degree with the axis of cathode neck with the axis of cathode neck. Okay, a provision is made to evacuate the tube to different degree of vacuum. So there is a provision to evacuate the gas filled X-ray tube to different degree of vacuum. Okay, the tube vacuum must be always less than 0.001 mm of Hg. Mm of Hg, mercury, para, we can say. Okay, so tube vacuum must be always less than 0.001 mm Hg in case of gas historical X-ray tube. Okay, in the gas tube, a small residue of air is always left. Okay, when a high potential is applied between the cathode and anode, the air inside the tube gets ionized and electrons are produced. Okay, so the air inside the tube gets ionized and electrons are produced by ionization. These electrons move at a high speed towards the anode and produces an avalanche of the electrons by collision with air molecule. Okay, the positive ions left are attracted to the cathode and release many more electrons by its impact. Means after collection, after attraction of the positive ion towards cathode, it produces more number of electrons. So the number of electrons is increased in this process. So in this session we had discussed about the historical gas existence. In next session we will discuss about the Coolidge tube or modern accelerator. Okay, thank you. Okay, so in previous sessions we had discussed about the historical gas accelerator. In this session we are going to discuss about the Coolidge tube that is proposed by the Coolidge scientist. That is a prototype tube of modern X-ray tubes like stationary or rotating anode X-ray tube. So the Coolidge tube is based on the thermionic emission principle. Okay, when a metal is heated, thermionic emission principle means when a metal is heated in vacuum to incandescence at a temperature, it emits large amount of electrons. Okay, such emission of electron by the supply of heat is called thermionic emission. Means when a voltage supply is applied on a cathode on an X-ray tube, and after a voltage supply, cathode emits electron or cathode filament is heated at a certain temperature, that is a appropriate temperature for emitting the electrons. So the electrons are emitted at a certain temperature after heating the filament. Okay, so it is called thermionic emission principle. These electrons can be collected by using another electron. Okay, that is the anode kept at a positive potential. It was proved that all the emitted electrons can be collected at a certain particular potential. Okay, so all the emitted electrons from the cathode that can be collected at a particular potential called the saturation potential. Okay, further increase of potential does not increase the current flowing between the electrons. Okay, further increase of potential doesn't increase the current flowing between the electrodes. So it is the saturation potential. After the saturation potential, the increase in potential doesn't increase the current flow in the tube, current flow between these electrodes. The Coolidge tube is completely evacuated so that there is no emission or no production of electrons by ionization. So evacuation or vacuum is required to avoid the collision of electron with the atoms or gases. Okay, so it can't produce the ionization. Okay, so it is a best fit. A spiral wire which serves as a hot cathode is heated to incandescence by means the current of the 4 ampere and 10 voltage. So voltage that is applied is 10 voltage and the current that flows is 4 ampere current. The filament commonly used is tungsten. Okay, the target is placed opposite to the cathode, similar to that in a gas tube. Okay, as like a gas tube, the target is placed opposite to the cathode electrode. Okay. Next, when high voltage is applied between the cathode and anode, okay, a high voltage supply is applied between the cathode and anode, electron current flows from the cathode to anode. Okay, so the after the high voltage supply, the current, electric current flows from the cathode to anode. As the electron reaches the target, X-rays are produced. These tubes are always operated at a saturated potential. Saturated potential, okay, that is a best feature or important feature of the these tubes. Okay, so in the Coolidge X-ray tube, there is two different electrodes like cathode and anode. Cathode is made up of tungsten filament and anode is made up of also a tungsten disc in the form of a tungsten disc. And electron beam flows between the cathode and anode due to the potential applied. Okay, this is the anode arm, or the second one is the cathode arm. Okay, that is a Coolidge X-ray tube.